Hello, everyone. We are trying out questions from this particular paper, which is February-March 2021 S2 paper. So now let's move to the very first question. This question says, a construction company, 3 days it takes to build each house of a certain design. So the results for a random sample of 60 such houses are summarized below. Calculate a 98% confidence interval for the population mean time. That is the first part. Explain why it was necessary, to use CLT, central limit theorem, in part A. Now, first of all, in this particular question, let me label the year so that anyone seeing this video will have a pretty good idea. This is which year are we talking about? February 2021. This is paper 6, which is S2, and this variant is 1-2. Now the question is, we have N equals to 60, sigma T is equals to 4820, and sigma T square is 392050. What do we need to calculate? First of all, we need to calculate the sample mean, T bar, that is sigma T over 60. We need to calculate variance, the sample variance. This is everything for sample. So therefore, this would be sigma T square over N minus T bar square. So let me write it first symbolically. So this one is N. And then I need unbiased estimates. Unbiased estimates, that is, this thing is the same thing as sample variance. That would be 4820 divided by 60. And unbiased estimate of sample variance, it's N over N minus 1 sample variance. I prefer to use this formula. So therefore, this one is N over N minus 1, which is 60 over 59. And this thing is 392050 divided by 60 minus T bar, which is 4820 over 20 square. And then, of course, you use a calculator and you would be evaluating these values. Now, this is the preliminary work. We are focusing on the population mean. Now, for the population mean, the formula is X bar plus minus Z sigma over root N. For 98% confidence interval, 98% is in the middle, and there is 1% on the left and 1% on the right. This is 1%, this is 1%, and this is 98% is in the middle. So therefore, this value is 2.326. So therefore, X bar or T bar, whatever the value is, let me look at a calculator. And therefore, this is 4820 divided by 60 plus minus Z value is 2.326. Sigma is what you have calculated initially, whatever that comes out to be. This is sigma square, keep that in mind. So sigma would be square root of this. Use the 4 significant value. And this value goes over here divided by root 60, and that will be the answer. So the answer comes out to be 77.6 and 83.1. This is the lower limit. This is the upper limit. Now, in this question, does it say that it followed a normal distribution? The answer is no. So was it necessary to use central limit theorem? Yes, it was necessary, as it was not stated that the data distribution followed normal distribution. So since normal distribution was not explicitly stated, so that is why we have to use central limit theorem. That was question number 1 of this particular paper. Let's look at this question. This question is about CRV, that is continuous random variable. The diagram shows the graph of a PDF f of a random variable x. We have the x-axis, we have the y-axis, we have the y-intercept, we have the x-intercept. Find the value of the constant k. Very, very simple rule, that is area under the graph should equal to 1. So therefore, this area of the triangle that represents probability, that should equal to 1. Therefore, half into base into height equals to 1. Therefore, k square is equals to 4. Therefore, k is plus minus 2, but we would only take plus 2 because that's what the diagram says. The diagram is showing k is positive, k as positive. It does not say so, but the diagram says it all. So the value of k comes out to be positive 2. Therefore, if I work on coordinate geometry, the gradient is half k divided by k. That is change in y over change in x. K cancels. That comes out to be half. The y-intercept is half k. That is half of 2. That comes out to be 1. So therefore, the equation fx is equals to mx plus c. And the gradient is negative because we can see it from the graph. Change in y over change in x is negative in this case. So therefore, this is minus half x plus 1. That is the function. So this thing I've already done. Fx is minus half x plus 1 or 1 minus half x. And it lies between 0 and k. The value of k is 2. Find expectation of x. That is also straightforward. Expectation of x is x multiplied by fx between the limits a and b. In this case, the limits are 0 and 2. X is x, and this is minus half x plus 1. This is minus half square plus x. It's not integrated yet. So do not forget to write dx, the integration sign, and the limits now integrated. So this is minus half x cubed over 3 plus x squared over 2. Between the limits, this is 0 and 2. And we use a calculator and we simplify it and we will find the value of expectation of x. So that was pretty straightforward. Let's move to the third part. Find the value of p such that probability x between 1 and p equals to 0.25. So therefore, your lower limit is p, your upper limit is 1, your equation is minus half x plus 1 dx, and this equals to 0.25. This is minus half x squared over 2 plus x between the limits 1 and p equals to 0.25. Now, a little bit of basic maths is there. Most probably a quadratic equation would be there. So therefore, this is minus p squared over 4 plus p. This is plugging in the upper limit. Plugging in the lower limit, that is minus 1/4 plus 1 equals to 0.25. We would simplify it and we would get an equation. This is p squared minus 4p plus 2 equals to 0. This is after a bit of simplification. And then you can use a quadratic formula. You can use middle term factorization, whichever is relevant, and you will find the value of p. Of course, you would accept the value which has to lie between the range is 0. So p should lie in this range. If there is any value which is not lying in the range, discard it. And that completes this particular question. Let's look at this question. This is question number 3 from the February 2021 S2 paper. An architect wishes to investigate whether the buildings in a certain city are higher on average than buildings in other cities. So higher, increase, upper tail test. That's how it sounds. He takes a large random sample of buildings from the city and finds that the mean height of the buildings in the sample. So they are talking about the mean height That means it would be either normal distribution or CLT. He calculates the value of the test statistic Z and finds that Z comes out to be 2.41. The first part, the question is asking is that explain briefly whether he should use a one-tail test or a two-tail test, and they are asking about explanation. So the person doing this hypothesis test should be using a one-tail test because it's asking about higher, because it's asking about an increase. So therefore, the question is one-tail. You cannot say that since Z is positive, let's use a one-tail test. That's the wrong logic. Because if it were a two-tail test, the Z value could come out to be positive or negative. So that's not the criteria. The criteria lies in the wording. Since it's talking about higher, since it's talking about increase, that's why it's an upper tail, one-tail test. Okay? So it's an upper tail, one-tail test. Carry out the test at the 1% significance level. Now write everything that is relevant down over here. Let me make some boxes that we usually make. So the first box should have the necessary info in it. That's the first box. Let me draw a second box. And let me draw a third box also. And the calculation is already done for you. There are no sample values, but the pertinent information needs to be given. Now, does it say that it follows a normal distribution? The answer is no. So to be on the safe side, I'll write it. Since n is greater than or equal to 30, CLT applies. Now they write now the number of sample. It's sample. Okay, random science and polynomial something comma, and what else is there? H naught. So mu is equal to something, H1, mu is greater than something. That is usually our working style, but all these things are missing. So what is the maximum that we can do? We can say it's an upper tail test, and the Z value corresponding to 1% significance level. This comes out to be 2.326. And our calculated Z value, that is 2.41. So if I draw a number line, and just a number line like this, and if I label this as the boundary value 2.326, this value over here is 2.41. Since the Z value lies inside critical region, therefore, reject H0, accept H1. And what is the question about? The H0 is about, it is of a certain height, and this is higher than average. Yes, the person's architect's suspicion is true. And what is the suspicion? In a certain city, they are higher than average. So there is significant evidence that architects' thought process or suspicion is true, and that the buildings are higher than average. Okay, that completes this particular question. Let's look at this question number 4 from the February 2021 S2 paper. The question says, on average, 1 in 400 microchips made at a certain factory are faulty. The number of faulty microchips in a random sample of 1000 is denoted by X. State the distribution of X, giving the values of any parameters. State an approximating distribution for X, giving the values of any parameter. What does it mean? It means that originally what is the question about? The distribution of x. That is the original parameters, the original distribution. So the original distribution is binomial. The probability of success is 1 over 400. The number of trials is 1000. So you would write x follows binomial distribution 1000, 1 over 400. That is what the examiner is asking of you. The second part, can it be approximated to anything? The answer is yes. Any other distribution? Of course, yes. Binomial has the liberty of becoming Poisson. Binomial has the liberty of becoming a normal distribution. Now, which one is more appropriate? First of all, calculate NP. That is 1000 multiplied with 1 over 400. That comes out to be 2.5. The rule is, since n is greater than or equal to 50 and NP is lesser than 5, this is your n and this is NP. They are fulfilling this condition. They are fulfilling the condition for becoming a Poisson distribution, approximate Poisson distribution. Therefore, x follows a Poisson distribution with 2.5. Why? Because NP is the same thing as lambda, the mean number of occurrences. So these 2 marks are for here. And make sure you state the conditions, whether the examiner has asked of it or not. It's always better to be safe than sorry. That is the second part. Now it says, use this distribution to find each of the following. Probability x is equals to 4, x lies between such and such, and then comes the D part. So let's first focus on this. X follows a Poisson distribution with 2.5. Probability x is equals to 4. Therefore, probability x is equals to 4. That is e raised to power of minus 2.5. And 2.5 raised to power of 4 divided by 4 factorial. That is the first value. And then you use a calculator. Probability x lies between 2 and 4. So probability x is equals to 4 is already calculated. You can calculate probability x is equals to 2. You can calculate probability x is equals to 3. E raised to power of minus 2.5, 2.5 square over 2 factorial. E raised to power of minus 2.5, 2.5 cube over 3 factorial. And then you would add this and this and this up, and you will get the answer. Probability x lies between 2 and 4. Because 2 and 4 includes 2, 3, and 4. All 3 values need to be calculated, added up, and take care of the accuracy. What about the last part? The last part is using a suitable approximating distribution. Now, something else is more suitable. Using a suitable approximating distribution, find the probability in a random sample of 700 microchips. There will be at least one faulty one. Now, in this scenario, what was the question about? 1 in 400 microchips are faulty, and the number of faulty microchips in a random sample of 1000 is denoted by x. So now the question is, okay, do we change the value of lambda? Now, lambda was initially for 1000. So basic ratio should be used. What can we do? We can say ratio proportion. This is number and this is faulty. So out of 400, 1 is faulty. Out of 700, how many will be faulty? Let it be x. So therefore, I can do the calculation and I can say 1 into 700 is equals to 400 into x. Therefore, x is basically 7 over 4, which is 1/3/4, which is 1.75. So for this part, I can say x follows a Poisson distribution, 1.75, at least 1. Probability x is greater than or equal to 1, which is 1 minus probability x is equals to 0, which is 1 minus e raised to power of negative 1.75. Whether you write the other part or not, it doesn't make a difference. This is 1.75 raised to power of 0 over 0 factorial. 0 factorial is 1. This value is 1. So basically, this is 1 minus e raised to power of minus 1.75. You get this. particular answer. Let's look at question number 5 of February 2021 S2 paper. The volume in liters of juice in large and small bottle have the distribution such and such. So let me write it down. Large follows a normal distribution, and this is 5.10 is the mean, and 0.0102 is the variance. Small bottle follows a normal distribution, 2.51 and 0.0036. So the first quantity is mean, the second quantity is variance. Now it says find the probability, and this is in liters, right? Yeah. Find the probability that the total volume of juice in 3 randomly chosen bottles. Now they're talking about 3 randomly chosen large bottles and 4 randomly chosen small bottles is less than such and such. First of all, define the variables. Let x equals to 3 large L1 plus L2 plus L3. Let y equals to S1 plus S2 plus S3 plus S4. 3 large, 4 small. X follows a normal distribution, 4 times 5.10, 4 times 0.0102. This is the basic calculation. Y follows a normal distribution. Sorry, the first one is multiplied by 3. So I made a small error. Let me correct it. This is 3. This is 3. And over here, this is 4 times 2.51 and 4 times 0.0036. That is the first thing. Now, when I add it up, so I say W is the total. So that is X plus Y. W follows a normal distribution. The mean is added to the mean. And if I use a calculator and if I add it up, this comes out to be 25.34. Similarly, if I add the variances to the variances, so therefore this will come out to be 0.045. That is the calculation on the calculator that you need. It is less than 25.5. Probability W is less than 25.5. Probability Z is less than 25.5 minus 25.34 divided by square root of 0.045. And this comes out to be probability Z is lesser than positive 0.754, which is simply direct reading from the table 0.754. And this comes out to be 0.775 or 77.5%. That is the answer given correct to 3 significant figures. So that's how the calculation for the first part is done. Let's move on to the second part. Now it says, find the probability that the volume of a juice in a randomly chosen large bottle, in a randomly chosen large bottle is at least, twice the volume of juice chosen in a randomly small bottle, randomly small bottle. So now it's 1 versus 1. That means it's a concept of multiple. So it's large versus small. So this is large versus small. That is the thing. Read the question again. Large contains at least greater than or equal to twice of S. Therefore, if I copy paste this thing, these first 2 statements, let me grab this thing. And if I paste it over here, so I need one more thing, that is twice S follows a normal distribution 2 times 2.51 and 2 squared times 0.0036. That is the first thing that needs to be done. The second thing, L minus 2S is greater than or equal to 0. Let M equals to L minus 2S. Therefore, M follows a normal distribution. The mean will be subtracted. So 5.10 minus 2 times 2.51. 5.10 minus 2 times 2.51. This comes out to be 0.08. So this is 0.08. So technically, expectation of L minus 2S, that is expectation of L minus expectation of 2S. But you don't have to go into this much detail. This is for explanation purposes only. Similarly, variance of L minus 2S is, that will be addition. That would be variance of L plus variance of 2S. So now what will you add? You will add this part and you will add this part. So when these two parts are added, this will come out to be 0.0246. And this part that you just did, that is this part. So now probability M is greater than or equal to 0. Probability Z is greater than or equal to 0 minus 0.08 divided by square root of 0.0246. If I do the calculation, this comes out to be probability Z is greater than or equal to negative 0.510. If I flip it, that's the rule. Z is lesser than or equal to 0.510, direct reading, which is 5 of 0.510. And this comes out to be 0.695 or 69.5%. So the first question was about summation. And the second question was about multiplication and subtraction. So that's how this question is to be done. Let's look at question number 6, which is the last question of February 2021, paper 6, the S2 paper. It is known that 8% of adults in a certain town own a Centaur car. That's the name of a car. So this is 8% is your success, and they are having this particular car. After an advertising campaign, and what is the purpose of this advertisement? To increase the sale. A car dealer wishes to investigate whether this proportion has increased. Therefore, it's an upper tail test. It's about proportion. That means it's a question of binomial. He chooses a random sample of 25 adults and notes how many of them own a Centaur car. He finds that 4 of the 25 adults own a Centaur car. Carry out the hypothesis at the 5% significance level. First of all, state the distribution. X follows binomial distribution 25, 0.08. The sample value in this scenario is 4. And we know that by default, this is inclusive. What else is there? We have to calculate the hypothesis test. And before that, we should state that the null hypothesis is 8%. Alternative hypothesis is greater than 8%. It has increased. And what else is there? There is this percentage, which is the 5% significance level. So 5% significance level for upper tail test, the Z value is 1.645. But keep in mind, this is not a normal distribution question. So the Z value is of no relevance. You have to apply the probability value method. So the probability value method, what does it state? If the calculated P value, the probability value, is lesser than significance level in a one-tail test, then the conclusion is reject H0 and accept H1 and accept whatever is written. So basically, I have to calculate the working. Probability X is greater than or equal to 4, which is too much to calculate. 1 minus probability X is less than or equal to 3, which is 1 minus 25C0, and then 25C1, and then 25C2, and also 25C3. This is your success, 0.08, 0.08, 0.08, 0.08, failure, 0.92, and so on. And what will happen to the success? The power would be this 0, and this 1, and this 2, and this 3, and 25 minus 0, this is 25, 24, 23, 22, and if I write down the value of this, this comes out to be 0.135 or 13.5%. Is 13.5% lesser than the 5% significance level? The answer is no. Therefore, there is not enough evidence to reject null hypothesis. There is not enough evidence to say that the percentage has increased. Okay? So that is the thing. And you will again say not enough evidence to say that percentage has increased due to advertisement. This thing is done. That is for 5 marks. Let's move on. The second part. Explain which of the errors type 1 or type 2 might have been made in carrying out the test. Now, what is the definition of type 1 error? Reject H0 when H0 is true. What is the definition of type 2 error? Accept H0 when H0 is false. Since H0 is not rejected, in other words, H0 is accepted, therefore, what kind of error might have happened? So we would say type 2 error might have occurred. That is the simple logic that we use. We don't go into details of further maths or very high level of statistics. This is the basic that we need. If it lies in the critical region, type 1. If it does not lie in the critical region, lies in the acceptance region, type 2. Now, another part for 3 marks. What does it say? Later, the car dealer takes another random sample of 25 from the town and carries out a similar hypothesis. Find the probability of type 1 error. Now, probability of type 1 error, reject H0 when H0 is true. I need to find the critical region for this binomial probability distribution hypothesis. Now, we know that we have already done some working, and that working is probability x is greater than or equal to 4, which is 1 minus probability x is less than or equal to 3, which is 13.5%. I want this percentage to be reduced. That means there should be more terms over here so that after subtraction it reduces. Let me calculate probability x is equals to greater than or equal to 5. I'm looking for the critical region. What is the minimum number that is required? So I'll say 1 minus probability x is less than or equal to 4, which is basically 1 minus, this is probability x is less than or equal to 3, that was already there, plus probability x is equals to 4. Now, why am I writing down the step? Because this thing was already done initially. This thing was already done in the first part. So you already have the answer for this. 1 is already there. Simply calculate this much. So just calculate this part. And then when you do the subtraction, this comes out to be 0.0451, which means 4.51%. So is 4.51% lesser than significance level? Yes, now we can reject H0. Wow, now we can accept H1. Now we can say, yes, the add works. Add has an effect. So what is the minimum number that we need? Find the probability of type 1 error. So the minimum is at least 5. At least 5 people should have said, yes, we own a Centaur car. So we would say the add was effective. And the critical region is x is greater than or equal to 5. And probability of type 1 error is actually probability of critical region, which is x is greater than or equal to 5, which you just calculated to find this value, which is 4.51%. So that is the true significance level, and that is the probability of type 1 error at that particular finishes this particular paper. Every single question that we have studied in this particular paper. Take care.